Alright, in this video we are going to discuss mean absolute deviation. The mean absolute deviation just measures how consistent a set of data is. To be consistent, that means we're very close to the average. So in class 1 I talk about the average score on this test was a 74. That means the majority of the people are scoring near 74. If I wanted to know how consistent my class scored, or a good idea of how many of my students are scoring close to 74, I would find the mean absolute deviation. Now, numbers closer to 0 when you find the mean absolute deviation, so smaller numbers, tell you that your data is more consistent. The closer to 0 you are for a mean absolute deviation, the more consistent your data is. The closer to the average everything is. That's an infinity sign, so as you get bigger, a bigger mean absolute deviation tells you that you are less consistent. So it's counterintuitive from what we think. When we look at 0, we think that's a small number, so we would be not as consistent. This just means that the amount of variation away from the average is small. And if the amount of variation we have is small, then we are more consistent. So that's where the backwards thinking comes from there. You can see we are skipping the second example that I have here, the top right box. We can find the mean absolute deviation using 3 steps. The first step is to find the mean or the average, and that's where the word mean comes from. Okay. So let's look at this very first example and find the mean from that data set. You might remember from 6th and 7th grade that to find the mean or the average, you need to find average. You add everything, and then you divide by the number of things you added. Okay, so we are going to add the numbers 60 plus 58 plus 54 plus 56 plus 63 plus 69. Where did I get those numbers? That's just the data set that was given. The data set that was given was 60, 58, 54, 56, 63, and 69. So I just put plus signs between all of them. This is where your calculators are going to come in super handy. I've already done the calculation tonight, so I'm going to just give away the answer without showing you my calculator. When you add all of those numbers, you get a value of 360. The sum is 360. So that took care of adding them all up. Now I just have to divide by the number of things I added. So I had 1, 2, 3, 4, 5, 6. Just to make sure I'm keeping everything straight, let's look at the data set and make sure that there were really 6 terms there. 1, 2, 3, 4, 5, 6. Perfect. So I'm going to take that sum, 360, and divide it by, I should have added 6 things. I did add 6 things. And now I've got a division problem, the quotient of 360 and 6. 360 divided by 6 is 60. So if these were test scores, then everybody, the majority of the class would have scored close to a 60%. Or so we hope. What we're about to find is how consistent the data set was. So to do that, we need to determine how far away everything was from the mean. How far away is 60, this first term, from the mean, 60? How far away is 58, the next data set, or point from the average, 60? We can see that 54 is a lot further away from 60 than 60 and 58. And then we even get a 59, which is, or sorry, a 69, which is way further away from the average 60 than the other points are. So we can talk about how to make our data more consistent, what could I remove to make our data more consistent, and what kinds of things could I add to make it more consistent as well. Long story short, the second step when we find the mean absolute deviation is to find a bunch of differences. the first step in this example gave us 60. 60 was the mean. When I write differences, we're going to find the difference between each data point and the mean. So we're going to have whatever the mean or the average is minus each different data point. So we're going to have a bunch of subtraction problems. We're going to have as many subtraction problems as I do data points. The mean is 60, so I'm just replacing that number with 60 minus my first data point is also 60. My next minus problem is 60, the mean, minus 58 is my second data point. So we're just going to create a list of minusing problems between the mean minus whatever the next data point in the list is. 60 minus 56, 60 minus 63. I'm going to put it up here so I have some more room. 60 minus 69. So now we can go ahead and find the differences here. When I find the difference, I'm really not concerned about if the difference is positive or negative, if I'm taking away more than I have. What I'm concerned about is how far apart each number is from the mean. And the way we talk about how far apart something is, the distance is always a positive. So that's where the word absolute comes from. In the words mean, absolute deviation. So we're specifically concerned about the absolute value of each of those minusing problems. Because the absolute value would make that difference positive even if it's negative, even if the normal subtraction problem is negative. The difference between 60 and 69 gives us 9. The difference between 60 and 60 is 0. 60 and 58, the difference is 2. 60 to 54, the difference is 6. 60 to 56, the difference is 4. 60 to 63, the difference is 3. So those are all of the different differences, or how far apart, those are the distances from the mean to each different data point. So already I'm thinking maybe this data isn't super consistent because I have something that is right at the data and I even have things that are 9 away. None of those numbers are really matching, so maybe this data isn't very close to our average. Okay, the third step is to find the mean or the average again. So we're looking to see how far is all of our data points deviating, that's where the deviation part comes from, the mean, 60. To do that, we're just going to find another average. Remember, to find the average, we have to add all of our things and then divide by the number of things we had. Well, all of the things now are going to come from step 2, all of our differences. So we are adding together then 9 plus 0 plus 2 plus 6 plus 4 plus 3. I've already done this tonight, so I'm going to just give away the answer. That is 24. 24 happened when I added all of the differences together, but that still doesn't tell me the average. So I'm going to take 24 and now divide it by the number of things that we just added. That was 1, 2, 3, 4, 5, 6. And that's good, that tracks, because we should have had 6 differences because we had 6 data points. Well, 24 divided by 6 is 4. So 4 is telling me this is about how far each of our data points are from the average. So we can see that that's not really super accurate because 9 is pretty far away from 4 and 0, but like 4 is right at 4. Not all of these numbers, these numbers just aren't very consistent with 60, our numbers here. It's been a long day, so I'm probably rambling. Right, we're skipping that second example, so I kind of let into that box a little bit. Let's now look at the example that has some decimals in it. So we are first finding the mean. To find the mean, we're just taking each of those numbers and adding them. So I've got 5, and then dividing by however many there are. So we need 5.8 plus 6.1 plus 5.5 plus 6.6 plus 7.3 plus 5.9 plus 6.3. Calculators are going to be super helpful with this just because it's a lot of adding, dividing, minusing, adding, dividing again. We've got a 5.8 plus 6.1 plus 5.5 plus 6.6 plus 7.3 plus 5.9 plus 6.3. The sum is 43.5. That's just the sum though, so we've added. Now we have to divide 43.5 by the number of things we added, which was 1, 2, 3, 4, 5, 6, 7 things. 1, 2, 3, 4, 5, 6, 7, that's good. So 43.5 divided by 7 is, we're going to round. So we're going to round to the nearest hundredths. I just picked that. So 6.21. So the average is going to tell me about 6.21. Just rounding. Okay. The second step, that was the first step to find the average. This might be, we'll talk about what these data points could represent in class. The second step to finding the mean absolute deviation is to find the differences between each of the data points and 6.21, the average. So we're going to have 6.21 minus 5.8. 6.21, the average, minus 6.1. 6.21 minus 5.5. 6.21 minus 6.6. 6.21 minus 7.3. 6.21 minus 5.9. And 6.21 minus 6.3. Okay. Remember, even if we get a negative number on our calculator, we're looking for the absolute value because we're finding a distance between the mean and the number that I've written down from our data set. And distances have to be positive. So we'll have 6.21 minus 5.8, which is a positive 0.41, sorry, 41 hundredths. And we have 6.21 minus 6.1, which is 0.11, 11 hundredths. 6.21 minus 5.5 is 0.71, 71 hundredths. 6.21 minus 6.6 says negative 0.39, but we're finding a distance, so we're just going to make it positive 0.39. 6.21 minus 7.3, 1.09. Just ignoring the negative because we're finding a distance, which means it's got to be positive. 6.21 minus 5.9, 0.31, or 31 hundredths. And 6.21 minus 6.3, 9 hundredths, 0.09. Okay. That was the second step. That's by far probably one of the longer steps because it's just so many different subtraction problems. But that's not difficult, especially with the use of a calculator. The last step is to find the average again, find another mean. So we're adding now all of the differences and then dividing by however many differences we have. So now we're going to add 0.41 plus 0.11 plus 0.71 plus 0.39 plus 1.09 plus 0.31 plus 0.09. There's a list of numbers to add. Again, that calculator is going to be super helpful. 0.41 plus 0.11 plus 0.71 plus 0.39 plus 1.09 plus 0.31 plus 0.09. And the sum of 3 and 1100ths, 3.11. That was just from adding all of the numbers. Now we need to type in 3.11 divided by 1, 2, 3, 4, 5, 6, 7, which is good because we started out with 7 data points and I had 7 differences. 3.11 divided by 7 is, again, we'll round to the hundredths for 0.45. And now we're going to look at the very last example. We've got 46, 51, 51, 74, 54, 69, 60, and 69. Okay, so we are first going to find the average by adding all of the numbers. 46, 51, 51, 74, 54, 69, 60, 69 again. And we add up 46 plus 51 plus 51 plus 74 plus 54 plus 69 plus 60 plus 69. We get a sum of 474. So now we're going to take the sum of all of the data points and divide that by however many there were. 1, 2, 3, 4, 5, 6, 7, 8. 474 divided by 8 is 59.25. So the average is 59 1/4. After we find the average, if we're looking to find the consistency or the average distance between each data point and the mean, then we need to find out what the distance between each individual data point and the mean is. So next we're finding differences. So we've got the mean, 59.25 minus 46. 59.25 minus 51. That same subtraction problem because the next data point is identical. 59.25 minus 74. 59.25 minus 54. 59.25 minus 69. 59.25 minus 60. And another 59.25 minus 69. If you've made it this far, I think you probably deserve to learn another calculator if you'd like to use it. I find it very helpful. This is obviously going to be something that's longer to type in, which is frustrating sometimes, especially if we start typing in things incorrectly. So to make this shorter on myself, I can actually store 59.25 as a letter on our calculator, one of those green letters. So I'm going to hit STO with the arrow. It says that 59.25 is going to go into place of, and we can just pick a random letter. So I usually use A just because it's right under alpha. To get to the green A, you've got to hit the green button first, and then you can click the A button. What this says now is that every time I type in A, the calculator is going to think 59.25. What that does is make it so all I have to do is type in A instead of having to type in 59.25. So now when I'm finding the differences, I'm typing in alpha A minus whatever the difference, or whatever the data point is. Minus 6, and that's 13.25. So that's really far away from the data point. Okay, so next I've got 59.25, the mean. So alpha A minus 51. That's the same for the next two data points because they're identical. Alpha A, or the mean, 59.25, minus the next data point, 74. The difference is 14.75. 59.25, so alpha A minus 54 is 5.25. Alpha A minus the next data point is 69. Absolute value, because we're finding a distance, so this is 9.75. And 59.25, so instead of typing in all of that, I can actually hit alpha A minus 60, 0.75, finding the distance, so make the absolute value, and again, we've got another minus 69, so that will give us 9.75. Okay, so that part is over now that I've found all of the differences between each data point and the mean. To measure consistency, I need the average distance between each data value and the mean. So I'm going to take the average of all of those answers. To take the average of all of those things, we first average all of the distances. So to find the average of that, we're going to first add everything up. So 13.25 plus 8.25 plus 8.25 plus 14.75 plus 5.25 plus 9.75 plus 0.75 plus 9.75 again. The calculator will come in very handy again. We've got 13.25 plus 8.25 plus 8.25 plus 14.75 plus 5.25 plus 9.75 plus 0.75 plus 9.75 for a grand total of 70. That was just from adding the numbers. Now we take 70 and divide that by the number of data points we had. 1, 2, 3, 4, 5, 6, 7, 8. So I've got 70 split into 8 ways, or 8.75. This is a long process. None of it's super difficult. It's useful for telling us how consistent our data is most of the time. Again, if you were looking to find how consistent your data is in a real-world setting, you probably wouldn't use mean absolute deviation. But as far as 8th grade math is concerned, this is a really good way to tell how consistent our data is. If you have questions, comments, concerns about the content in this video, please don't hesitate to reach out to me. You can message me through Schoology, stop me during or before or after class, please not during class, or reach out through any communication method that is posted onto Schoology.